All right, good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon to try and figure out the future for smart buildings. It's really good to have you with us today. If you are wondering who we are, our profiles are listed on mondaylive.org. So please head over there. And please remember that views expressed here in this hour are personal, not of any company or organization. And let's make use of that Zoom chat because it wants to be used so that we can have a dialogue on what we're talking about today. And if you want anything that's on this slide deck, it's also available on mondaylive.org. So this being April 25, we are talking about ontologies all month. So this is our third week doing that. So our agenda today is we'll talk about sort of normal news and trends, what's going on in the industry. Then we'll talk about ontology for buildings. And then we're going to continue what we were discussing last week, which is really the intersection between ontology and AI. And we're going to have somebody that's going to come and join us with a certain perspective. So looking forward to that and the discussion. But before that, I'm going to hand it over to Ken Sinclair. What's going on, Ken?
Well, as always, lots up in the top right-hand corner there. We're all trying to explain AI in English, but it doesn't speak English. That's a pull quote from something Kimon wrote, and I think it's a good focus for us all to keep on. The next one is the summary of last week's Monday Live. That came out, I thought, quite well, and summarizing most of the stuff that was going on. It introduced the Tiger Team and that effort, and then we were able to have C4SB put together with ChatGPT a summary of that, and that was very well received. A lot of folks were quite interested in that. We actually then did a little bit of a flip back to Too Long Did Not Read summary of Can Autonomous Buildings Become a Reality with AI? And why I put that in there is it's kind of a pre-read, I think, to some of this other stuff that's going on. The other one that we got going on was Google in the last few weeks has come out with a agent-to-agent protocol, and there's been some discussion on that. We have an article written with that and written about that, and that's between my opening comment that AI doesn't speak English and the fact that now AI is going to be communicating at a direct level. I think that may add a little bit of twist in our thought, and maybe we can talk a little bit about that today. The next one that we had, well, actually we're still supporting the Smart Building show up in in the UK. They're just starting to put together their October show. They're looking for sponsors, speakers, everything. So if you click on there, we are a media sponsor of their event, and we're pleased to be that. We're trying to see how we can interface with them. Gary's kicking around the idea of going to that session, so we'll see where that's at. BAS Career Tracks, that's a post by Phil Zito, and he just talks about getting these new people from zero to to useful folks in our industry in a very short time, and I think he's achieving that, and he's doing amazing work, and I think the industry needs to applaud him for the effort he's making and the change and the people he's bringing into the industry. I think it's always been a kind of a daunting industry to get into, but I think another thing that actually Anto and I were just discussing before we turned on the show here is AI is such a great tutor as we start to use it. It teaches us what we need to know as we go. It's such a dynamic thing. Is you have questions, you ask AI questions, and then it teaches you, and then you start asking better questions, and all of a sudden you have artificial intelligence trying to sometimes put together what it is you've actually created. It takes a little bit more thought, but meetings like this, I think, help us keep that going. The other one there that shows that bull charging through the maze, I kind of like that because that's kind of some, I don't know about you guys, but some days I kind of feel like that. It's just it's all a bit overwhelming, and there's a lot of stuff going on. That's actually about the servers side of the business and how they have to change with all the changes. Something across my desk said that half of the traffic now is artificial. That's going across all the networks and through the servers and stuff. So that's an interesting one. And then exploring the future of multi-agent communications, I think is another area we're going to need to expand. And I'm certainly looking for folks to come on as the contributing editors that can help us pick our way through this jungle. Anyway, back to you, Anto.
Thank you, Ken. A lot going on, as always.
Just out of interest, sorry, Anto, but did you folks see the interesting article by, what's his name, Sam Altman from ChatGPT about the amount of energy that they have to use for people being polite to ChatGPT when people use words like thank you, please? Apparently that burns up a whole bunch of AI energy just processing it just to be nice to the machine. So he's like, stop it.
I always do that because I figure someday they're going to be in charge.
Yes.
But they are now. That's what the A is. Agent to agent language is.
Yeah.
They're talking at that level and they're not using English. We have no idea what they're talking about us, but we don't know what they're saying.
But it's initiating it now. Like we were just talking about this at our morning meeting. I was working with some co-pilot doing some programming, and it's like, now you're thinking like a boss, CTO, that's the right way to do it, Keith. And I'm like, yeah, I already know that, but it's like complimentary, like I already know that, but yeah, you're really thinking like a CTO now, such a great application. I was like, yes, thank you. Yeah.
Wow. All right, should we move on now? Did you know that this week is the 5-year anniversary of Monday Live?
Oh my God!
Wow.
This is show number 224.
Wow.
I can't believe that we've done 224 of these.
That's crazy.
We started in April 2020. We survived COVID together, and we've been making buildings a little bit smarter every week. I hope. So
Well, I'm impressed.
Leave it up here for some comments from the group, because 5 years is a long time, guys.
We actually started meeting slightly ahead of that, right? Yeah. Back in March. Wow.
I had to glance up at the board. We started Facile April 8th, 2020. So it's right. In fact, that coincided with, I think, one of the first Monday Lives. I think I just started Facile. Yeah, because I left my last company at March 31st was my last day. So 2020. So right in time for the COVID.
Yeah. So did you keep attendance records, Anto?
Somewhere it's in the Zoom database.
Yeah. Well, I'm sure if you fed all the transcripts, AI could figure that out in a hurry.
I was going to say, I mean, what are we waiting on?
Yeah.
Yeah,
it
no,
was,
I was looking at the YouTube channel. We have a YouTube channel, and all of the 223 shows, past shows, are there. So
Oh,
we're just scrolling through them. Anyway,
But the interesting thing there, though, of course, is besides Keith, who was just kicking off on AI, I don't think we were using any of the terminology back then, right? Keith was way ahead of the curve.
as usual, right? No, it's something because I actually visited a former customer of mine and current customer, USC, and they wanted to start up this smart cities program. And so I was all, this was in February of 2020. I was like, oh man, great. I'm going to start up at USC. And then COVID hits and they shut the campus down for like a year. It's like, oh man, what am I going to do now?
all right. Well, congratulations, all of us.
Yep.
Congratulations for the audience for putting up with us. But in terms of updates, Rick, do you want to just touch on this? We should have Paris to come join us in the second half of the hour. So
Today?
she can touch on
That's-
this as well. But if you can just give us a brief.
Yeah, that's great. So the second week of the Tiger Team happened on Friday, and again it was like 26, 28 people. So we lost a couple people and gained a few people, and some of the people that were at the first one were just kind of lurkers anyway, and the people that were certainly on the second call were all intending to dig in and get some work done, which got a little more definition of what the outcome is expected to be for the Tiger Team, and even started to kind of frame out what the outline for the white paper, or as Paris 2 says, the artifact that we intend to have as a result. And some of that's starting to take shape. Getting more and more clarity around how some of the different existing semantic work starts to fit together, and it was just kind of lively discussion around, and I thought real positive around the things everybody has in common in terms of the goals of why this effort is valuable and what we can get out of it, both in the short term with the Tiger Team and then the longer term with working groups in C4SB and/or in other entities. So really exciting to start to kind of get into the work. We still have not given Brian Turner any time to talk. I think
he
I just saw.
responded today at least. So.
Okay. So we're going to make sure we get Brian some time to talk on this next Friday. Aside from that, yeah, it seemed like real productive.
Have you unleashed it to ChatGPT to do a summary of that meeting?
Oh, good question. And Jory and I were talking about that, and thinking that waiting until a couple more meetings have happened and then turn it all into ChatGPT is what we were thinking. Now, of course, we've done a little bit of cheating and fed some of it to ChatGPT already, but since we're still kind of in the early stages, it's sort of it's coming out with a little bit of messiness, let's say, because we're still in early days of this.
Okay, so that we'll get a bit more update on this when Paris 2 hopefully joins us later. The link board as normal. Any other thoughts? Anybody want to bring up? Hearing none, let us move on to ontologies, and we're going to be talking about ontology and AI part 2, part 1 being last week. I'm going to bring on Michel Kohanim as a panelist here. Michel and I have been exchanging messages and posts and comments on LinkedIn. And he has a certain sort of perspective about ontology in the context of AI, and we thought we'd invite him to explain it himself and have a discussion with us.
That's great.
Hi, Anto.
Hey.
Thank you.
Hey,
Long time no see.
indeed.
Long time, 20 years almost.
I'm gonna
Thank you for
stop
the
the share,
opportunity.
so we're all here.
Well, I think my background or our company's background is home automation. So we've delved into and developed many different protocols for communication with devices, Xten, Insteon, Z-Wave, Zigbee, Zigbee Pro, Zigbee SCP, dot, Thread, and now Matter, and BACnet, Modbus. And then in addition to those, we've developed integration with utility communications like OpenADR1, OpenADR2A, 2B, and now 3, SCADA, SCP 2.0, just name it. I mean, we've been just developing back and forth all these different protocols and communications and trying to get all of them to work together in kind of a seamless manner. And I call it Groundhog Day, because it's just this cycle keeps repeating. We just keep doing the same exact thing with different protocols, with different minute details of different things. For instance, Z-Wave has command classes and Zigbee has clusters. And Xten uses everything as hexadecimal, or and then Insteon uses some other format. And then we have Haystack that uses YAML. And then we have SCP2 that uses JSON. So all of these are varieties of the same concepts for communications. So as soon as I saw Anto's description of ontologies, I just got triggered, because it reminded me of all the times that we had to go through all these classifications and categorization and figuring out how to abstract out clusters versus command classes versus commands versus everything else. So in my view, I'm not gonna say, first of all, to me, AI is a perfect tool. It's not a solution for everything. It's just a good tool that we can use. And one of its most important characteristics is classification. So then my question to Anto was, why do we need to classify things to give it to AI when the AI can itself do the categorization and classifications? Specifically, if you look at all these AI frontier models or even small models, they do not use semantics, they use syntax. I think Kevin spoke about it beautifully on in last week. It's just mathematical probabilities of what comes next. And then you can have different versions. Some of them are bidirectional, most of them are not. So my question was, why do we need to create ontologies for something that itself can create ontologies based on the context? So thank you. That was my speech.
Anna, you were nodding your head, or?
Well, we were talking about this on the last call Wednesday, right? About is to Mikhail's point, is there a real need for ontology when AI doesn't use ontology, right? And I think the way I summarized it at that point, Mikhail, was that ontology, weirdly enough, is the human interface for the thing so that we can understand it. The machine doesn't need to know it, but we need it as humans, and therefore we kind of came to some conclusion maybe ontologies are still needed only so that we can discuss it between ourselves, right? So that maybe, and it was a bit of a maybe, right? And I think it was worth further discussion.
And I think, in my view, if well, we actually worked on not requiring ontology and instead expecting we call them plugins to describe themselves in English. And so I would take issue with Ken's statement that AI is not English. I think AI is natural language. So if AI understands natural language, why do we need to, I mean, why not just use natural languages to describe everything, right? For instance, when I talk to you, can say change the temperature to 25 or 72. Based on the context, you know that the only thing that you can change the temperature to right now is your thermostat. Right? I don't have to explicitly say change the cool set point on your thermostat to 72. I don't. Right? Because you have the context, and AI is pretty good at extracting context. So
Yeah, that's exactly right. I remember like we were just talking about when I started Facile, but I was actually working on a Chat GPT type agent a couple years before that. Okay, I was trying to use tools to help our technicians scale. We had 16,000 buildings, and I get my exercise with the enlightened PRVs. So I'm working on that too, by the way. I do have a Bluetooth. I have finished up my Bluetooth signal strength analyzer, so I'm gonna wire that thing up today. So hopefully come up with it. But anyway, I mean, yeah, I was trying to use it because even if we classified, I mean, a lot of the stuff we had to do was classify thousands of millions of points. I said thousands. It was 3,000 points per store. So it's 3,000 points times 16,000 stores. So I mean, it's just millions. So even if we did 90% of it automated, we still would have like 30 million points to do manually. It's a non-starter. So I started on this. So we had a little agent that you could tell it stuff like that. And to your point, Michael, about context, we had a drugstore customer, and it's like change all the set points in all the stores to 74 degrees, except for the pharmacy. We want to keep
yep.
where they were. I didn't have to tell it what the other zones were. It knew in context. It knew to only do it to everything that's out there. It's a bag of points, right? And just don't touch the pharmacy unit. So I mean, that was really kind of the start of Facile, working on that stuff. But yeah, it's the context, and I wanted the objection was always that it's going to be too complicated. They already didn't want to use it because I don't need no stinking computer to tell me how to do my job. I just need the front end. So I had to make it engaging, easy, and actually, I'll say, but simple. I use that word. I'll be nice since we're being recorded, but I mean, seriously, like it had to be error proof. And I'll leave it at that.
I'm with you 100%. And another analogy is, for instance, if you use Nest thermostats, they also have forecast and they also have occupancy. So what is it exactly? Is it a thermostat? Is it an occupancy sensor? Is it a weather station?
Yeah.
So how do you create ontology on top of something like Nest? Then you get into Zigbee Zigbee aggregations. And so you have to define minute points and then aggregate them into a cluster, right? So, and if you go that route, then what happens to Optimus, a robot? What is Optimus? Are you going to have a category for a screw or for the hand or the fingers or nails or everything else? It's just not scalable.
I actually had the privilege, it's something you mentioned, Nest. I actually had the privilege of working with Nest before they got acquired. In fact, I had one of the first Nest thermostats because we were trying to work on a commercial retail version of the Nest thermostat, and we were actually working with Nest. And Nest wanted, I was the CTO at the time of the company, and they wanted me to kind of experience that experience. And I got one of the first Nest thermostats in my house. It was like 8 years ago or something like that.
Yeah.
I mean, but they wanted Nest in doing this partnership, and it never went through anywhere. But yeah, they wanted me to experience the difference between, I had a little, $15 thermostat from Home Depot on there, and I changed it out to this Nest thermostat. It was just such a different experience. I mean, it had the little screwdriver with it and all this stuff. And you hooked that wire up wrong, even though I'm supposed to be somewhat of a technician. It's like, that's the Y. You got to put it on the other one. And I mean, it walked me through. It was just amazing, and that's where it go. So.
And one more example of categorization leads to my brain blowing up is like EV, and I have V to G, vehicle to building, vehicle to grid, building to grid, vehicle to vehicle. And so what are they? Are they storage? Are they EVs? What are they, right? So it's when you get into categorization and it becomes really, to me, an intractable problem. It's not solvable based on everything that I've seen out there. It's extremely difficult. So that's
I'd just like to make one point that we made last week as well, which is I do buy that ontology is less necessary in the world of AI, but the metadata is still very important.
of course.
Part of the conversation we're trying to bring along here is that metadata as well as the ontology, right?
Of course, metadata is extremely important, and to me, metadata is the context. So when I talk about context, is the context, metadata provides the context for your communications and interaction with the system.
Right.
So the question is, how do you describe the metadata? And in my view, just use English or use any natural language. Although you can make it structured, make it JSON, YAML, or whatever you want. But metadata is extremely important because that it provides the context for your communications.
And I think that one of the things you have to have is sufficiency of metadata. But we talk about data sufficiency. So in terms of standardizing, one might not have enough if you didn't give people the opportunity to have some idea of what the applications are and what enough is.
So we're literally having this conversation with a new partner of ours, is an international client. They got this nice, shiny, great API as an IDL that they actually put on top of a backnet system. And yeah, our AI, we use AI, of course, and machine learning for classification. And it failed miserably last week because when they streamline the interface to now, you don't have, it's not compartmentalized. There's no hierarchy. So at least on a device level, if I had a location and then a device, and device number 1 is on air handler number 3, I know that the points are constrained to that air handler. So I actually use the device to classify all that stuff. And because now I was dependent, since they had this nice new API on top of it, not making a dig on them or anything, but sometimes they didn't put AHU 12 or whatever in the point name. So now our classification fails because there's not enough data sufficiency. Like we literally just had this conversation. So yeah, we have to make sure that, and it was inherent in I didn't know that while I was actually the AI is traversing, heuristics or whatever, going down the line, that I was constraining my data set to only the points that belong to that particular unit. And I was, using it to classify and tag the unit numbers and the unit type and all that stuff. So yeah, we can't forget on our march toward these, well-defined APIs to miss out and lose some of that data. So yeah, now tomorrow morning I'm gonna have to go back and say, yeah, I need you guys to manually tag this stuff because it's not in the data set. It's not in the point name.
Right.
Mikhail, this is Steve Fay.
Sorry.
Michelle.
Michelle.
Hi, I'm Steve Fay. So you're making the argument that ontology is less important in this because of the power of AI. Okay, from a user perspective, the users being a building owner in one case and say a consulting engineer in another. Okay, the fundamental question that each tends to have is the end user wants to know, what do I have in my building? Okay? Mm-hmm. And the consulting engineer wants to accurately specify what should go in the building. Okay? Mm-hmm. So from what you're seeing in terms of, or what you're advocating for in terms of tagging the metadata, do you feel that'll be sufficient to answer those two questions without having to go to a full-blown ontology on top of it?
I must confess that I'm not into large buildings, or although we do small commercial buildings, my expertise is integration between devices and communication between devices. So I wouldn't know I don't know what they need. So I don't know if AI is sufficient, and I'm not gonna claim that I know.
Okay.
But from integration and communications, how to communicate with devices, how to describe devices. Number one, based on our experience, number one, the most important thing is whatever defines devices should be typeless. You cannot have something that says, I am a thermostat, because what is a thermostat? It
Right.
should explain or describe itself with regard to it, regarding its capabilities, the commands you can send it, the commands it can accept, and then all those can be defined in natural languages. Again, I don't know about large buildings. Our largest building is about 5-story commercial building. So I don't know.
Okay, fair enough.
So we have been joined by Paris 2. Hey, Paris 2.
Hi, everyone. Thanks for having me, and sorry for joining late.
No worries. It's really great for you to join us here. We'd obviously love to get your thoughts on what's going on in the Tiger team. But since we're in the middle of this conversation about AI, and sort of applicability of ontologies to AI, do you have any thoughts, or do you want to pass on it?
Sure. Yeah, I do have some thoughts. So for those of you who don't know me, I'm Paris Sudal, I'm a research engineer at National Institute of Standards and Technology, also known as NIST. I've been involved with a bunch of sort of standard development that are more like in terms of an ontology, ASHRAE 223P, as the most recent work that I'm involved with. Now, in terms of the question, I mean, I agree that there is, with new advancement in AI, and especially the large language models, we're seeing a lot things that we were not able to see before. But at the same time, that was brought up, I think, earlier by one of the panelists. I think it's important to have a context or a way to describe the context. And the most important thing, I think, that the thing that we cannot achieve with tags is that relational aspect between different data points, right? So when we have a full-blown ontology or an actual model, not only we understand that this is a point from air handling unit 1, but we also can traverse that graph in the, like if it's a RDF ontology, and get to know what zone that AHU is feeding into, or like a lot more information, what sensors are along that sort of route. So that contextual information of not only knowing what that data point is, but also how's that related to other points that we have. And to me, I always like to think is, natural language processing, all those techniques are good. They're tool for certain use cases and not tools for other use cases. As humans, we have all these concepts of of things that are around us, right, in terms of the knowledge that we have, and we process that knowledge. And having these sort of full-blown ontologies and kind of encrypt that or pass it to an algorithm is like we're giving the machines that knowledge in advance. Now, we always can refine, it's not guaranteed that what we pass to an algorithm is the best. As it sees more data sets coming from the BMS or other sources of information, it can refine the sort of data specific, data model for that building. But I still think they're very crucial. Someone can say, just having a metadata is enough. I like to think that ontologies by far are the more efficient and more descriptive way of, having and describing the metadata. So that's my 2 cents.
Yeah, absolutely. I would agree with that. And having done this at scale, I mean, our model building is all automated. I mean, everything's automated. So we have to have one concept is we have what's called an area tag that we assign to everything. So an air handler unit, what area do you serve? Thermostat, what area do you serve? Everything. So that allows us, and so we have this concept I call extreme tagging, and we just hashtag. We literally hashtag everything in the. I remember John Petsy used to explain, when he was doing SkySpark, he would get out the Excel spreadsheet and start doing his hashtags. I mean, it's the same concept. So not very hierarchical or rigorous from that perspective, but it's just, if you need a tag, add a tag. And the thing I think where we as an industry kind of diverge is where I've got to call the air coming out of the fan supply air temperature, and I can't call it discharge air temperature. That's where we go off the rails. It's my tag. I'm using it. I can call it anything I want to. I remember at JCI and Honeywell, Honeywell was SAT, and Johnson Controls is DAT. I mean, are we really not going to be able to communicate because we don't agree on the name of the air stream coming out of the fan? Like, that doesn't make sense. So we got to have flexibility. And again, I think we've solved that with everybody has their own set of tags. So they use their tags. In fact, our tags in our system are actually arranged by user. So if you don't like my tags, make your own up, and use your tags, because it's all in context of what you're trying to accomplish with the system.
Yeah, and exactly. And if you have like what we're doing in 223, I don't care what your tag is, right? I'm caring about this property that has a quantity kind of temperature, right, in unit of Celsius or Fahrenheit, whatever it may. And it's a property of this connection point of my air handling unit. I am calling this, not calling it anything. So depending on what you're using in your system, whatever you want to call it, is a discharge, is supply, whatever you want to call it, I know this is a temperature reading at this point, at this connection point of the AHU. So that's, the advantage of having these sort of robust and, in detail models of, we're not going to go after the syntax of what you call it or what I call it. I care about the context. I know what I'm reading is a temperature because that's the way it's been defined in the ontology. I know exactly at this point I'm measuring it. So that's how I'm going to do my logic and reasoning based on the information I can get from the RDF model.
And what? Oh, sorry. So by I, who are you referring to? I mean, if Kevin is doing all the logic, what is I in here in your explanation?
The analytics company, right? So a lot of a lot of folks that we are involved with, they want to know what they are measuring. What is exactly what is the point that what kind of quantity kind it is, where exactly it is, right? So that's what we're trying to give based on what we get from the BMS data or the schematics of the system. Again, we need better tooling to populate those ontologies. There's no doubt on that. But assuming that we have that, right, then we can pass on that digital artifact to them and say, you can go query. And when they query the graph, they know what they're getting at this point is a temperature reading, and the exact same is like at this connection point of the AHU or along a connection that's coming out of the AHU. And go ahead.
Yeah, sorry. And what happened? And this is only a specific protocol like BACnet or Modbus. What happens if you have
This is protocol agnostic, right? So what we do in 223, we say this reading, if you want to implement BACnet, this is the way to do that, and that's go to the device ID, property ID, and all those things. If you want to use Modbus, there's another. So we are kind of shifting away to endorse a specific protocol.
So what happens if you have Nest? Do you have to have a translation layer between Nest APIs?
I don't know what Nest protocol, what protocol they use. But in terms of, we have examples of BACnet that we are working on, showing, if you were going to have a BACnet system, or we're also working on examples of Modbus, this is the way we would do that. Basically, what we say this is a definition of this point is a temperature reading. If you want to know the value, this is sort of an API call to, this data set or whatever link that you want to go and read the current value of. Or if it's a BACnet, this is the information of the BACnet system. So it's kind of external to what we capture. What we talk about is the definition of what that point is. And if you want to know the value or exactly where it's coming from, is kind of an external link to that, what we call an external reference. So the details of what that value is or where that value is coming from is kind of external to our work.
Yeah, I think it's more along the lines of localization, right? So our customer and international customers using Celsius, for example, it could be the same thing. It's like an ISO tag for language, right? EN for English, FR for French. That's why we try to put everything in our data in the database as in a generic fashion. So I remember a huge debate about this, like what should be the timestamp stored in? Obviously UTC. I can't tell you how many times I argue with people. They want to put the local timestamp in there. It's ridiculous. I can translate it based on user back to their local time zone by their settings. They literally have a user settings, or I could do it by browser or whatever. But that's localization, what you're talking about. As long as you store it, like for energy, it might be, I don't know, joules or something, or BTU. Like we have to have the concept that gets stored in place in a universal format that can be translated to others, so you can have simultaneous people. Like I don't want to be looking at 21 degrees Celsius when I'm working through my stuff. I want to see it in Fahrenheit, and our system easily accommodates that. It doesn't matter, because as long as we know the format that is stored in the database, then it's just a simple transformation to whatever the user's local preference is. So that's how we handle that. And I come at this from not from a theory point of view. Like I've been doing this for decades. So I mean, we had to solve all these problems because we were engaged with customers, enterprise customers, to do that. So I think it's more along the lines of localization.
This is great conversation, but I feel that we're getting into the weeds a little bit here.
Maybe, but the weeds matter.
Yeah, I was going to say, I think the details are important.
Implementation detail.
We all know that, but like to sort of go up a bit in level, and Parasu, could you sort of give us an update on really what's going on in the Tiger team that
Sure.
initiated?
Yeah, so about 3 weeks ago, we started sort of this exercise of inviting people under. So Linux Foundation, I don't know, like what level of the knowledge is for this groups. So there are, with the help of C4SB, they want to start this initiative and work on sort of the technology stack, sort of speak for smarter building. And one important element of that is this amazing work that's been done by different groups for ontologies and different ways they capture things. So about 3 weeks ago, we started this Tiger team, inviting people from different activities such as Brick, Project Haystack, Zito, 223P, Real Estate Core, like to name some, of the different work that's been done. And the purpose of sort of a near-term purpose of this group is to come up with some sort of an artifact, can be a white paper, a position paper, to go and look at the different work that's been happening, and it has happened, and kind of highlight what they achieve and what they aim for, but at the same time to talk about the gaps and what's missing in this space that can advance the industry, specifically the building owners, and kind of elaborate on that to see what's missing and what are the next steps that we can do, sort of forming more targeted, specific working groups that would tackle those challenges and shortcomings, to kind of kick this off and move it towards a direction that's going to be usable by the industry and of a value to the building owners. So it's that's what we're aiming for after 8 weeks or so, to achieve that and kind of publish that work and put it out there for the public to review, so they familiarize themselves with the different activities, the different work that exists, but also at the same time what's missing and what are the different tasks we're aiming to do to kind of fulfill the gap that is not there. So that's what we're doing. We're meeting every week to kind of go through sort of the plan and kind of form our position about this issue. And we're hoping after 8 weeks, definitely we're aiming to publish something that's going to be, we think that's what the industry is thirsty for, kind of, consume that as a like, oh, this is happening, this is what's missing, and like these are the next steps from there. Any questions? Any thoughts?
That's great. Rick, do you want to add to that? And then we'll open it up to.
Yeah, good to see you back. And yeah, there's a Realcomm meeting in June that, as Paris 2 said, in 8 weeks, 8 weeks will finish up right about the time that Realcomm big tent show is going to happen. And so having some sort of, as I said earlier, the Paris 2's words, an artifact, or as Jory says, a white paper, which I'm not sure if that's the same thing, but I think it is. But it's been really good to see the looking forward, looking at what the gaps are from all the good work that's been done. But we're really looking forward towards when software can be done differently using new sorts of capabilities. And that's the important thing from my perspective, from the Linux Foundation's perspective. That's what we're trying to advocate for, is that software solutions can be done differently and hopefully better, or in a more interoperable way, in a more open source and open standards based way. And so it's as fun as it is. And Michelle, it was fun to hear you say X10, because I've brought my X10 devices to show people. They're sitting right over there, one room away. But to be able to talk about all the different challenges we've had over the last 40 years of this industry of trying to do integrations, what Paris 2 is talking about is the looking forward part. How are we going to be doing things different in the future? And again, as the Linux Foundation, that's really what we want to focus on, is saying, hey, there are tooling, artifacts, white papers, examples of how to do things differently in the future, to build on all the great things we know how to do now, but to take them into the future. And Paris, you've said it better than I've ever said it in the past. Do you want to take it back?
No, you did great, and thanks for covering the things I didn't cover. Yeah, I mean, as you said, it's just not the focus on ontologies, but how we can use ontologies for better softwares, open source softwares, how we can use what was been referred to killer demo applications, right? We want to show industry this is possible, this is the way to do it. Here are some examples on some real buildings, and just give them the glimpse of hope for them to look at and kind of use and build upon. So that's the goal here.
Perfect.
Anybody else?
One comment, Rick. Forward-looking, is Matter included in your forward-looking vision of the future?
So we're really focused on commercial buildings, but Matter always comes into, because again, you just heard me say, I was putting X10 stuff in my dorm room when I was 16. Well, when I was 14, I started buying it. So looking at how it impacts the homes and multifamily especially is something that I think everybody's conscious of, but we're kind of going after the commercial version first.
Okay.
And the other thing I wanted to add on, I think it was brought up in some of our discussions, we want to give sort of the building owners and the people investing in the technology that level of confidence of like hoping to get tools as interoperable as possible. And no matter what technology you're investing on, right, there is a way for interoperability and like, transitioning from one way or ontology or schema to another. We have proper tooling, we have the proper stack to do so, right? So that level of confidence and kind of de-risking the process of people getting worried about, should I go with Project Haystack? Should I go with Brick? Should I go with 223? You know, which one I should, or none of them. And just that element of fear and then, you know, uncertainty. What we're trying to do with sort of this exercise, also an educational element to that of like, these are the existing words. This is what exists. This is what's missing. And so sort of give that element of confidence to them that no matter what they want to invest in something, right? Because as we know, at the current stage, very small percentage of the buildings have even haystack tags, right? So how can we bring that awareness to them to be more pro and, you know, investing in different sort of efforts that are out there, no matter what they are?
A path to interoperability, if
Exactly.
nothing else. And
Exactly.
and there are a lot. And as the Linux Foundation, we don't pick one path. We don't pick winners, is one of the things we've talked about. So, but we would like to be able to show how any choice that somebody is making, or anything that they're saddled with when they realize what they've got in their building, that there is a path and that there's a roadmap. Well, the Linux Foundation calls them blueprints, but we're not going to use that term in this industry. But showing how there's a path to interoperability, a path to better graphs, better RDF compatibility, whatever it is, there's a path towards more interoperability.
Absolutely.
Jim, Tracy, David, you have a view on all of this?
Well, I'll start. I started a month ago when we first started talking about this, with the position that we won't need ontologies in the future. But the more research I did, the more I learned that that's not true, that ontologies are important to an AI world, to enable AI and moving things forward. And I continued to ask AI intelligent questions about why, and if, you know, what's your position if you are taking the opposite of needing ontologies? And it comes down to a couple of things, I think. The uniqueness in our industry of every single building makes it difficult for AI to do what it does best, which is learn with large amounts of data to identify itself, right? So that's one problem that's putting the checkbox on we need ontology side of things. The scalability is the result of ontologies, making AI much more scalable, much faster, with limited need for learning on the fly. If you're doing nothing but houses, or in my case, like nothing but fast food restaurants or whatever it might be, that might be a different story. There's enough there for AI to learn and understand and know what's going on. But if you're going building to building to building, it would, with everyone being unique, it makes that a little bit challenging, I think. So I continue to lean towards the we need ontologies to make things go smoother, faster, and more understandable for humans, obviously.
And I would add to that, we also need much better tooling to populate those ontologies. You know, having ontology and having a schema is one thing, as we are, you know, coming to our hopefully second advisory public review for the standard. Having good tooling to populate good ontologies or sort of data graphs are as equally important, if not more, to go along with those.
Yeah. And coming back to the Tiger team a little bit and tying that in, you know, the work that the Tiger team is doing right now defines what buildings of tomorrow can do, will be able to do, right? So it's really foundational, I think, to pull this together and stop everyone going in different directions and find commonality and moving forward.
David, you have?
Yeah, what's interesting is so many buildings or assets have, been designed over the last 70 plus years. And there are usually naming conventions that are different for every building, or if the same engineer did multiple buildings, they all have the same naming conventions, and then you run into challenges. And the reason why I'm bringing this up is there's the concept of master data, which doesn't change regularly at all. And that's how we know how to identify and know what an AHU1 is versus FCU versus whatever. But the master data naming conventions and ontologies are a historical thing tied to every building. And then a lot of what we're talking about, from my understanding with the Tiger team, is more around transactional data, energy usage, temperature, and data that's exchanged much more frequently. And when you think about the master data side of things with ontologies and then the transactional side of data, what are we tying things to? And when I look at what the priorities are as an owner, I would care about the facility conditions report that I get when I'm buying a building. And so how does all of this Tiger team data help contribute to an engineer being able to quickly put together that facility conditions report and also create or potentially create a facility conditions index, which requires assembly numbers, using uniformat, et cetera, and then also, how does this map to CMMS apps, IWMS apps, and CPIP maps? So when we look at ontologies, we need to, ideally, I would love to get a Rosetta Stone from the Tiger team that explains the core data and whether it's master data or transactional data, and then also how it then is used by those different outputs, the CMMS, IWMS, CPIP, and a facility conditions report and a facility conditions index.
Was this seems kind of reminiscent of something I think we talked about years ago. What was it called? Build spec, Anto? Remember that?
Yeah.
Remember that
build spec? It was
that's like 20 years ago or something. But yeah.
this is where I'm deep. I'm deep into uniformat, master format, omniclass, and uniclass for tracking assemblies for cost management during design and construction.
Yeah.
David, you'll be pleased with what the fact that Dennis Sheldon he's on. That's where his sort of mind is, and he's participating in the Tiger team. So the work that's being done on IFC5 to RDF and some of the details of what he's been able to describe fits in nicely with what Paris 2 is describing in terms of the tooling to build better knowledge graphs that can go across what have usually been completely separate data sets or
silos.
Well, there's still some silo to silo work that has to be taken.
I know. I just wanted to say silo.
We're really trying to get to some consistent tooling, as Paris 2 said. Now, if we're focused mostly with the Tiger team on mechanical systems and building systems, and including security and some other domains and maybe cameras and things like that, but we're not ignoring all of that, but we're trying to get to a consistent level of the use of more consistent tools. Again, plug for the Linux Foundation. Cool thing. A lot of Linux tools being used in other domains. They're trying to solve this same sort of issue.
Paris 2, do you have any sort of comments to the different types of information that David was talking about?
Yeah, I do, and specifically for 223 work, we have here and there we have looked into some information that we're actually modeled regarding the CMMS, right? Sort of asset management. We do have people that are heavily involved with the facility sort of management and operations as part of our team. So they usually provide their input as like, this is the information I care about, so you better model that. So just to put it out there, we are considering some of that in part of our work. I think brick schema is less involved in those things, and that's okay. We try to cover different areas that are related to building. As Rick mentioned earlier, we also are in 223 work capturing knowledge about lighting and electrical system as well. So those are the other things that we have. And again, what we try to do with sort of like more transactional data, the way we are capturing things is to talk about more about the nature of that data in terms of the quantity kind. Is it temperature? Is it energy? Is it power? And sort of that thing, sort of what it is, and not so much what we name it to be, and where exactly that sort of data is being measured. So that's the approach that we're taking in 223 to be able to give as much freedom for people to describe the points that they want to measure and talk about in terms of units and quantity kind, and the actual placement of the sensor that point is being measured. And also talking about the topology of the system, right? So how two different pieces of equipment are connected to one another. And we also have this notion of directionality that would help the person to understand the sort of equipment sequencing. If this is downstream or upstream of a specific piece of equipment is downstream or upstream of another piece of equipment. So those are the information that we can query the graph for. And as you said, maybe hopefully helping in sort of generating certain reports. So we are not having a specific focus on like make sure this is happening versus not. What we are hoping to see is as we sort of publish this work, people will start using it for different applications and get back and say, hey, I can't find this information with this graph. And from there, hopefully we'll have a standing committee that go through revisions to kind of change the model to fit what's needed within the industry that our model is not capable to answer to. So that's what I can add to that.
That's great. Thank you very much, Parastu.
Sure.
We need to bring this to a wrap because we're way over time. It's been a very interesting conversation. Thank you, Parastu. Thank you, Michelle, for joining us. Thanks everybody else, and hope everybody has a good week, and we'll see you next Monday, and we'll get a video up in the next couple of days. Bye-bye all.
Thank you.
Thank you.
Take care.
Bye.
Bye.
Bye.